Okay, we're on the press right here. Here's our needle bearing. You got a round side and a flat side. The flat side is the side you press against. So you're going like that. Put our pressing tool right there on top. A little extension one on here. Of course, we don't have enough room. And then we go ahead and push that on down with the press. Put the camera down here for a minute. Alright. So see if we centered it. Go down most of the way and stop. We got to make sure that our pressing block clears the cutaway for the cam on the back side there. Go ahead and push in the rest of the way. Push that more even. And we're starting all the way. So now our bearing's in there all the way. So that's how that looks like there. As long as your bearing is flush with the gasket surface, you're good to go, because the washer sits across it. No reason to go past that. Flush is fine. So we're going to check the cam cover next. Alright, got everything all cleaned up here. I'm going to do a little bit of a trial fit here. See how things line up a little bit. So I'm going to put the cam in here. Got our inner thrust washer here. You make sure the flat spot goes to the back. That way it clears the lifter that goes up and down and hits it if you don't do it that way. Got our new cam here. We need a thrust washer for the end of it. We'll just grab a 50 thou one to start with, just to kind of see how it is. Got our S&S gasket kit here. Make sure you put that on right. And put this on dry. Make sure you get all the screws in the right spot and the right length by looking on the back side. You want to see about a finger worth of screw hanging out on all of them. Or about 5/8 of an inch. Half to 5/8, what I like. These all have washers underneath the heads. Now, the first good sign was the cover went right down. Didn't have to force it. Cam's nice and free, so you can just turn it like that, no problem. A lot of free play in it. So that means our alignment was really good that we did. So the cam, I put an extra half a thou clearance into it because I prefer to have them slightly loose and tight. They do occasionally want to stick in the brass bushing, so. Doesn't really hurt it to be loose. I'm going to jump up to a 65 thou washer. It's easier doing this now than when it's together. It's always best to check it now because it's a hell of a lot easier to fix the problems now than later. Still get a lot of clearance. Go to 70. What the hell happened? All of a sudden things don't want to fit. There it goes. Bound up on a dowel probably. To an 80. Pretty huge shims. Yeah, 80 thou. Go ahead and tighten this down and we'll see what it feels like. Losing some clearance now. Yeah, we're too tight now. Some torque on these. Bottom one doesn't really matter. We have only about 3/4 thou clearance. You can see with the camera a little bit. You can see in there or not. Anyway, it turns nice and free. There a little bit so you can see it. Spin it with the pinion, little screw on the outside there. So we're going to have to take at least 5 of that out. Too tight. Okay, now we're going to go ahead and check the pinion shaft bearing. Kind of hard to do that with a cam in there because my finger can't get in there now. Makes it really hard to do. Gee, let's use a wrench. Drop our bearing in there. Grab our shaft. Bearing fill out. Second attempt. First attempt sucked. Okay, it's in. Bearings in here. A little closer. You can see how that's all the way in there. It spins nice and free. Here, a little bit of clearance on everything. So that's a perfect fit. We know the bushing's really tight and it fits in there real nice and clean. So everything aligns really good. So that's a big plus. So I got put an extra 5 or so into the cam in here. I like to run them slightly loose, so I might go 10. That's very little clearance. I like 8 to 12, and we're kind of right in the middle of that range now. So I'll go ahead and take this off, try the next one down, see what I think of it, and go from there. Okay, I just changed out the shim and the cam here, drop down 5. So I like 8 to 12. Now the way you check these with a feeler gauge is you come in here with your feeler gauge, down the rear lip lock hole. Right here, you go ahead and stick it down in there, and you see what you got. Now if you go down between the case and the washer, it's kind of a false number, but when you get real in there, you can feel it get tight. Right here, between the washer and the thrust plate, it actually locks up the feeler gauge. If you go between the cam, same thing, it gets tight. This is a 7th thou feeler gauge. So it's a little bit under my normal number, but this is going to be a low RPM motor, so I can tolerate it being a little bit tighter. If this is going to be a hot rod motor, I'd put another 5 in here. But for now, this will work, so I'll do that. A lot of this stuff I do by feel, but it helps to, it's always better to be loose and tight on this kind of stuff. So, anyway, we got the cover down here, so we're going to go ahead and move on to the next problem we got, which was our left case bearing. So let me move this out of the way here. Alright, we're back to our left case here. This insert here is getting to be, it's trying to get loose, but it's not loose yet. I heated it up and it didn't move. I burned the oil out of it. I got this cleaned out real good with brake clean and everything else. No more oil's coming out of it. Looks like I did bake it too, which got a lot of it out. But you can see how it's got kind of a gap in there between the aluminum and the steel there. You can see it. You can catch it with your fingernail. It's flat across, so it hasn't moved. And when you hit it with a hammer, it rings really good, which is always a good test for something being loose. That's where you take it and just tap it with a steel hammer. Relatively decent ring. So what I'm going to do is I'm going to put a little sealer in this thing. There's 2 types of sealer I can use. I can use Loctite 290, which is a capillary action penetrating Loctite. It's made to fill up weld porosity, cracks and holes and stuff like that, which is what I usually use. This stuff here is new stuff. This is from Lock and Stitch. This is made for steel. It's made to go down inside between the 2 pieces of metal, and it sucks in there and seals. With the absence of air, it'll seal. So that's what I use for pressing in those stitching pins and stuff in that Model A Ford I did. So I'm going to go ahead and try that, see how it works. And I know it sucks in there pretty good. I'm going to go ahead and see what happens here. There is no way of really knowing how good it works, because the motor will be destroyed if it doesn't work. Right now it isn't fully loose, so it'll work alright for now. I didn't do anything. It's just kind of a backup type thing. Right now I'm shaking up the bottle really good, like it said to in the instructions. Sometimes it helps to read them things. Okay. Let's go ahead and see how this sucks in there. Looks like it's sucking in pretty good to me. Or all the way around, you can see it already sucked in this whole side already over here. So I'm going to go ahead and put another layer in. Sucked in through here too, it looks like. Over here not so much. Just kind of smear it around over there, see what happens. Smear it over here to the part that matters. So I'm going to let this sit for a few minutes. I'll come back and look at it and see if it's sucked in anymore. If so, I'll put a couple more coats on it. Right now it seems like it went into the pores, so that's a good sign.